Hello, welcome to the Compile Log channel. Today I will show you how to get Jupyter notebooks with TensorFlow, working with GPU acceleration, with CUDA acceleration on Windows machines. It is quite simple, though when I was trying to do this, I spent way too much time on this because the existing guides are either wrong or unnecessarily complicated. All you need is, and I will actually show you two methods. They are quite similar in the basis. They are quite similar in the ideas, but the execution is slightly different. The simplest way how to get this possibly done, all you need is Docker running with WSL2 and NVIDIA drivers installed. That's it. No extra steps, you don't need to install anything in WSL2. It should work out of the box. Now, assuming you have this set up and Docker active, you can pull the repo that I have linked in the description and use this Docker compose in this compose only folder. I will explain how it works. There is the base image TensorFlow GPU. I use latest. You can select any reasonably recent version. The important thing is to add the capabilities GPU so that, well, you have the GPU accessible. Now, there are a few environment variables. What is important is that you pass all the devices to be visible, or you can select some GPU. I have one NVIDIA GPU in my system, so I selected all. And you need these capabilities, compute and utility. Now, these volumes, not strictly necessary, but I would recommend if you actually want to run something, you can pass some volume. Not necessary, and you need to expose the server on some port. The default port for Jupyter notebooks is 8888. I kept it, and this simply maps the internal port 8888 to the external one. This all would be the basically just using the existing image. However, this would not work on its own. The important thing is that you need to set up the Jupyter to actually run within the container. This is again sort of minimal configuration. Use the local IP, allow root, this token password. This is set up for the easiest possible login. Again, you can select something, but as long as it's locally, it's just easier. And now where the magic comes, the entry point. For the CUDA to work, you need to install this package, TensorFlow and CUDA. So by default, I upgrade pip, which is a package manager for Python. Then I install the necessary library, and then I will run the Jupyter notebook. Simple as this. Nothing else. How do you run it? You open folder with this file, and you type in Docker compose up. Then the process of pulling this image, unless you have it pulled already, will start, and it will take some time. Even on reasonably fast computer with gigabit Ethernet, it can take a couple minutes. Of course, depending also on the speed of remote servers, yada yada. After this is done, the machine will start. I did not delete this. I can simply start. Once it's pulled, then it's much faster. So I can do compose up and the machine will simply start. This is where I see it. Within the logs. For the first time, you will see these install logs, and as you can see, it is already satisfied because again, I've ran it ahead of time, not to wait. Installing this again will probably take a couple minutes, but once it's ready, you will see the host URL. You can click it and you will see this website with the notebook. But you can also use it, and this is what I prefer in the Visual Studio. I have also prepared a Python notebook to check that all the functionality that should be working is actually working. If I select run all, the first time it would actually ask me what server I want. Again, I would put in the IP, the local host, and also the port to which I map it. in this case the 4/8. As you can see, the CUDA is available, GPU support, it's CUDA 12.5, and all the other tests pass too. This works and is all well and good. But there is actually even better way to do this. The logic stays pretty much the similar, but first we will build our own Docker image, and for this is this Docker file. We will base it on the same Jupyter notebook, set the same environment variables, so you can see these ones. I just have them in this code. Again, some directories, not so important. The expose, the 4/8 port, the default one for Jupyter, and the command that before was in the compose now is here. So it will take even longer for the build, but once it's built, you can just start the image and it will be pretty much instant, maybe a few seconds. Again, I will show how should it look. This time I had the image already pulled, so that didn't take too long. Docker compose up. The command is the same, just in different folder. It will execute the command. So as you can see, it took 300 seconds for me, and it should look exactly the same. The difference is, now that you have a different image, I will stop the first instance. You will actually even see it in the images. This is the original one. This is the one that ran for my first demo, and this is my own image that I've built. As you can see, it's much larger because, again, it pulled a lot of extra data. It will look exactly the same because it is exactly the same. The only benefit being that if you do Docker compose down on this, you will not need to re-download all these Python libraries. You will just do compose up and it will again start very quickly. All the source codes are available on my GitHub. I hope this video helped you. Enjoy the rest of your day. Happy developing.